So we can't talk about near boiler piping without bringing up the fact, and there's a lot of controversy on this. I'll just give it a quick explanation. You be you, do what you want to do. But most manufacturers will caution you against using copper in the steam piping. Now, when I say in the steam piping, that means it's okay on the condensate, but not on the steam side. So there's a lot of people saying, well, I've done it for years, I've seen it for years, it's not an issue. Well, that may or may not be true. When a steam boiler fails, do we know why it fails without getting into um, a lot of detail and research and just looking for a problem as to why it failed? It's easy to point the finger at the manufacturer, but we know that when steam goes through copper pipe, it leaches copper molecules out of the pipe, which ends up back in the boiler, and then that can cause electrolysis and cause a boiler to fail. Now, when we say it's been done for years, it's not been a problem. The one thing that we see with boilers today is many years ago, go back 30, 40, 50 years ago or more, when steam boilers were very plentiful, they were big. They held a lot of water. So when these molecules got in there, these copper molecules, it had to take a lot of them to really affect things. Today, the boilers hold a lot less water. And I'm saying it maybe a fifth of the water they used to hold in some of the manufacturers. So would that problem be more prominent now moving forward? Yes, it would. Yeah, if the same amount of molecules come back, there's less iron to attack, so therefore the problem would seem worse. The other things I want to address real quickly here is let's look at other failures on steam boilers, which we will address somewhere else in more detail in another seminar. But the first one is oxygen corrosion. Oxygen corrosion takes place at the water line. The oxygen disengages from the surface of the water and it causes rusting of the heat exchanger at that point, and you will get little pinholes around the water level. The one that's been talked about more in recent years is chloride corrosion. And chloride corrosion is normally the top of the boiler, meaning it corrodes from the inside out, but all the way at the top, maybe a little bit around the corners, around it, I know, but the corners of the heat exchangers. That's usually due to chloride corrosion again. Chloride corrosion is a hole. It gets bigger over time. I've seen chloride corrosion issues where you could stick your fist through a hole, and a lot of steam was going out the chimney. So these are not related to the manufacturing of the boiler. These are related to the installation of the boiler, adding too much fresh water. Again, a subject we'll talk about in a different seminar. So let's talk about near boiler piping. There's some very important information that we have to gather from the install manual before we start the job. And the first one of those is what we call normal water level. The manufacturer will always give you the normal water level. It's going to vary from boiler to boiler. If they have two steam boilers, one gas, one oil, let's say, it may be different for each of those. It depends on the design of the boiler, how tall the sections are. So that normal water level will be measured from either the floor that the boiler is sitting on, or if it's up on block, it may go from the block up to the normal water level, or from the bottom of the jacket. I've seen it done all the different ways. But they're going to give you this measurement, and everything that you install as far as the header and the T for the Hartford loop is measured off that measurement, the normal water level measurement. So we got to make sure that when we install the boiler, we know what that normal water level is, and that's where our measurements are done from. I used to put a magic marker line on the water glass so we could see where that measurement came from. And then we usually measure from the ceiling down to get our measurements for the header and for the T for the Hartford loop, because the floor could be very unlevel. So you're going to level the boiler, but now we have to find something that's fairly level to measure to. And one of the easier ways was to measure down from the ceiling then and determine where our measurements had to be. So normal water level, Very important information to have before you start. Next, we get to the boiler supply, and this is telling us that the boiler is supplying the steam from the boiler. It's a pathway to get to the header. So we could have one boiler supply, two boiler supplies, or more. Some people call these boiler risers, but they just send steam to a different area. The velocity in these risers is very important to keep to a minimum. We like to stay under 25 feet a second. So if a manufacturer calls for one riser, then you can use one riser. Can you use two? Yes. You can keep that velocity lower, get a little drier steam. You can go to a second riser, even though it calls for one. If it calls for two, make sure you don't do one, because therefore what happens is the velocity increases. And then we end up with some short cycling on the boiler, possibly because we can't get enough steam out of the boiler fast enough, or the velocity of the steam is so great that it pulls water out of the boiler. And in that case, it could end up in the system or back down to the boiler. So we don't want wet steam, and that's what it would be caused by having the velocity too high. Next, we're going to come to the boiler header. The boiler header is a collector for the steam. So it's going to collect from multiple risers or a single riser and collect this steam and send it down the pipe. So again, there may be multiple risers to this header, but we want to have them all in a row and then go down to our steam fitting. Our system riser is like the boiler supply riser. It's going to take steam from the header out to the system. You may have one system riser. You may have 2, 3, 4 system risers. Each steam loop should have its own T on the header. You shouldn't come up in T. We'll show you that a little bit later. System supply. Again, we may have multiple supplies. They might be teed together somewhere. Just separate them all, bring them back to the boiler. The equalizer supposedly equalizes pressure on both sides of it. So you have the same pressure on the supply as you have on return. I mean, that's going to happen. We're going to have the same pressure there. We're going to give a pathway for condensate to go from the header back to the boiler. So we want to get that water back into the boiler as soon as we can so that we maintain the proper water level in the boiler and we're not causing the boiler to overfeed to an automatic water feeder and flood the system. Next is the Hartford Loop. The Hartford Loop was created by Hartford Insurance Company, and they came up with this idea because people were being killed by steam boilers. Steam boilers were exploding, and the reason they were was the return line came straight across into the bottom of the boiler. So if we got a leak, all the water would drain out of the boiler. These were coal-fired boilers back then. We didn't have the safeties we have today at the turn of the 1900s. So therefore, somebody would go down, put water in the boiler. They'd hit hot steaming hot boiler with ice cold water. The boiler would blow up, and there was over 4,900 people killed back then with boiler explosions. So they come up with this idea of the Hartford Loop. The boiler water would only drain down to where that Hartford Loop is, so it would leave water in the boiler so they wouldn't blow up. Today, we don't have a lot of water volume in the boiler, but it's still a good idea to have a Hartford Loop because low water cutoffs do fail, and it gives us time to actually see that that boiler needs water. So use Hartford Loops today unless we have a condensate pump or a boiler feed tank. We do not use a Hartford Loop if we have a pump putting water back into the boiler. And last but not least, we have a condensate return. And there's two types of condensate returns. One could be on the floor and it would be called a wet return because it's below the boiler water, the level that's in the boiler. If it's above the level in the boiler, we call it a dry return. So the only reason we have these two different names is it have water in it all the time or does it not have water in it all the time? So therefore, we would call that a dry or a wet return. We're showing a wet return here. On the last slide, we talked about normal water level. the manufacturer sets that normal water level. Again, just a reminder, pay attention to where they measure to. Is it to the floor? Is it to the bottom of the jacket? Wherever that is, they set that. So whenever we're installing the Hartford loop, we want to make sure that we have that measurement from the normal water level down to the Hartford loop. But what happens with the Hartford loop is protecting the boiler from dry firing. If we get a leak in this return line, and right now you can see our water level is fairly high in the boiler, but let's say it drains down because of a leak, and then what's going to happen is we're going to drop that water level, but we're still going to have water in the boiler. So if that boiler fires, the low water cutoff will not trip yet. They'll still give us some heat, and hopefully we can catch it before the low water cutoff shuts off, or if the low water cutoff fails, hopefully we catch it before the boiler gets destroyed. So it's important to know where that normal water level is. The Hartford loop, there are specific directions to follow to properly pipe the Hartford loop. And first thing we have to start with is make sure we follow the piping directions on the install manuals. I know steam piping hasn't changed in over 100 years, but you still have to look at the directions and maybe readdress those. Maybe you've forgotten some of it, but they give you all the information you need. Don't reinvent the wheel. Pipe it the way it shows it. Don't alter that in any way, shape, or form. Steam systems are the least forgiving systems when it comes to improperly installed. So we want to follow the manufacturer's specs. When we do the Hartford loop, we always want to be 2 inches below the normal water level to the bottom of the branch of the T, down to where that water would stop coming out of the boiler. So 2 inches below that. Commercially, I know this isn't commercial seminar, but it's going to be 2 to 4 inches commercially. But follow the manufacturer specs. I don't know of anybody that moves away from that 2-inch mark. But again, if they give you something different, you use that. It's best to trap the water, but it's not required. And what we mean by this is when you come out for your Hartford loop, and let's say you have a dry return, can you come out and go up? Yeah. Is it really suggested? No. We would suggest you come out, drop down to the floor almost, and then go horizontally, then go up and pick up your dry return. A wet return's already below the water level, not an issue. We just don't want to get any steam up in that dry return because that'll stop the house from heating. Always use a close nipple or shoulder nipple or a Y fitting when you bring off your Hartford loop off the T. Now, Y fittings are almost impossible to find back when I was a tech 25, 30 years ago. Today it may be easier. I don't know. Some manufacturers offer kits that already have a Y fitting in it. But if you don't have a Y fitting and you want to keep that Hartford loop close, take a Street 45 and screw into there, or a Street 90 if you think you can get it in, and drop your pipe down and have room for other things. But I always use a Street 45. Screw it into the T, put a close nipple, put another 45. That'll point you 90 degrees down to the floor, and then you can do the rest of your piping from there. So you always want to keep water between the steam and the return. Now, if that return's a dry return, that's where the concern would come in. Don't use longer nipples. Again, we say shoulder or close nipple on that Hartford loop, or the 45. That's pretty close. If you get too long of a nipple in your Hartford loop, you're going to end up possibly with water hammer. That sounds like somebody took a hammer and beating the pipes in that Hartford loop area. So avoid using anything longer than a shoulder nipple. One thing I want to mention as we get into these drawings on near boiler piping, they're not complete. They're not showing you your valves, and they're not showing you drains and that type of stuff. It's just for educational purposes as far as the piping itself goes. So here we're drawing a single supply going out to the system, Hartford loop coming back. This is just a proper way to pipe it. Now, With that being said, I'm not great at doing 3D drawings. So this drawing, it shows the boiler supply coming up and going straight into the header. You should have an offset there. It should come up to an elbow, go a short distance to an elbow, and then turn into the header. To properly do that, again, look at the install instructions from the boiler manufacturers. So you'll want to have an offset there. But other than that, this drawing is a good way to draw it. We're not showing the valves and stuff. Drop that return or drop that Hartford loop down to the floor. That's just not a bad way to do it. Or if the wet return's down there somewhere, just drop down as far as that is. As long as you have a water seal always between the boiler piping and the system piping. So if we do have a dry return, you can see it's above the water level down in the on the right side of this drawing. It comes out, goes up directly. Is it okay? Yeah, it is. I mean, theoretically, it's fine. I've seen systems that way. They work. Am I concerned about them? Yes. And the only reason I say that is that water level drops and a little bit of that Hartford loop becomes open to air. So there's only water in, let's say, the bottom half of that branch coming off the T. You're going to get steam down that equalizer out into that pipe that goes back up to the dry return, and there'll be a vent up there. So hopefully it would vent out. But if it doesn't, because steam moves pretty rapidly, now that steam goes up and starts pressurizing your return. When you pressurize a return, that means you have the same pressure or maybe greater pressure in that dry return pipe before that first radiator, which would be the last one on the feed side. Your system's going to stop heating. It's going to block it because to heat, you have to have a difference in pressure. The steam coming out of the boiler, that side of the system always has to have a higher pressure than the return side of the system, which is after the last radiator. And we actually have some returns going on inside the main piping around the house, depending on if it's counterflow or parallel flow. But we don't want steam in the return line. So once it drops down at the other end or gets past the last radiator, we really don't want much steam there anymore. So let's drop it down to the floor at the boiler like we saw in the last slide. We're showing a boiler with two risers. It could be a single riser. Again, I'm not great at doing 3D drawings, so this is my attempt at swing joints. But when we get to the end of the header, we've got steam and water parallel flow through that header at a fairly decent rate of speed. And then it's going to slam into the back of that T. And as it does, your steam's going to go up. It's a lot lighter, a lot more buoyant, but it's going to carry some of that water with it. It's also going to become wet. So the water's going to splash in through the steam. It's going to pick up some water molecules and head out into the system. As this happens, it gives up its latent heat to the water. The latent heat should go out to the system. And if you're not sure what I'm talking about latent heat, go to our basic steam information and boiler sizing seminar. But as it gives up the latent heat, it crashes back into condensate. So now we've got all this water up in the piping, but wet steam, as it crashes back into condensate prematurely, it moves slower because it's heavier than dry steam is, and therefore our fuel bills go up. So we don't want wet steam in the system. We want dry steam. And manufacturers today must produce boilers 98% dry steam when it leaves the boiler and the near boiler piping. So the near boiler piping is actually part of the certification to verify they get dry steam. And we'll talk about other ways to make it a little drier later on. So we don't ever want to put a T at the end of the header. We want to take the T off to go up to the system, as we showed in the last slide, and then the equalizing pipe going down to return the water back to the boiler. I've actually seen this type of piping way more times than what I'd like to. The boiler had two system supplies. So it goes up to the T and branched off in two different directions. We need to get that T out of there, cut those pipes off in place, or break the T off, or whatever we have to do to get space. But we've got to bring them down to the boiler independently. And people may say, well, and I've heard this more times than I'd like to admit, it worked okay before. Well, the old boiler's not there anymore. So we can't even think of that analogy. What changed? Water volume in the boiler, the type of the size of the castings. So when we create steam today, we're creating it faster. It's moving faster through the system. You're going to end up with unbalanced heating and possibly more water up in the system. As we send that steam up that 2-inch pipe at a certain velocity, and then it gets up to the top where that T is in this drawing and starts going two different directions. We just went from a 2-inch pipe to two 2-inch pipes. So that velocity is going to change. And if it draws water up, we got wet steam. We just talked about that on the last slide, how it costs more for the homeowner to heat the building by leaving it this way. The fix on this is to cut that pipes apart, bring two T's down to the header, and then pipe two T's off and go in your separate directions. That would be the best way to make sure that this system heats well and evenly and at the lowest cost for the end user. This slide is just showing two boiler risers with connected to the header, and then we have two system risers off to the right. We have two boiler risers coming out of the boiler, but we only have one system riser. And this I've seen way too many times, where it was piped that way before. They just cut the boiler riser, slid another boiler in there, and said, okay, we're done. We don't want the steam to go in two different directions. So in this drawing, we have steam going up the riser on the left. So when it gets up to the header, it's going to the right. And then we have the one on the right going up. When it gets to the header, it's going to the left. And the steam crashes together where that T is going up to the system riser. We've carried some condensate with that. Of course, the one on the left side of the boiler is actually carrying condensate towards the right. You are going to pick up a little bit of condensate going back to the other side from the one on the right, and you end up with wet steam. We talked about the problems with wet steam is increasing the customer's fuel consumption, taking longer to heat the home. It's just unsatisfactory heating. So we should never, ever do this application. If it's there, cut it out, shorten the system riser, move the T further down the header. As we move it down the header, again, do not go all the way to the end and put a T at the end. There should be no T's in the vertical location in that header going up to your system. They should always be in a horizontal location, so they're pointing up and going away. It's great to take them off at a 45. Most people don't, but it still works okay if you take it straight up, but not off the end of the header, please. Keep it back 6 inches or more from the end of the header. Here we have two boiler risers. We're just going to two system risers. And I'm just showing them that none of them are between the T's. They're both after the boiler T's. All the steam and condensate's flowing in the same direction. And we don't have them at the very end on a T. We're about 6 inches back from the elbow for the equalizer. The one problem we run into today is the older style boilers that you're tearing out probably have a higher normal water level than the one you're putting in. And that may or may not be a problem. Whenever you have a system, and you have to kind of look at that system as to how it's piped, that one pipe steam, two pipe steam, not sure what one pipe, two pipe steam is, go back to our steam basics and boiler sizing seminar. We explain it there. But you want to keep the water level about where it was. It's a good idea to measure how far that water level in the old boiler is off the floor. Maybe put the new boiler up on blocks or 2 layers of blocks to get it where it needs to be, where it was before. If that's too much difference from the old boiler to the new boiler, and you don't feel comfortable getting the boiler up that high, then you have to do what we call false water level. And the false water level is exactly that. It makes the boiler believe that the system water level and the boiler water level are the same when it's sitting idle. But it doesn't have to be. It's a false water level for the system. So we'll have our boiler water level where it needs to be, and then we'll have our system water level where it needs to be. Where this comes into a problem is if you have all your connections on the system at the higher water level, we're coming back and tying into returns, and everything was wet or everything was dry where the connections are. What was dry before must remain dry, and what was wet before must remain wet. Now, what you'll see sometimes in this situation is where you'll have a crawl space and a couple of returns come down and tie into this return piping, which normally was below the water level of the system. But now with this smaller boiler, they become dry. So what you would have is you would have steam coming down that riser, tying into this return line that was wet, but now it's dry because we don't have that seal anymore, that water seal. So now the steam comes down the return a little bit, goes up the second pipe, which is actually was a return before, and now we're pressurizing that return. And those two radiators will not heat, or 2 loops of steam will not heat because we've got the same pressure on both sides. We're not creating that difference in pressure to make the system work. So whatever connections were wet before must remain wet, and whatever was dry before must remain dry. So this is a false water line. Let's assume, and I didn't show it in the drawing, but let's assume that the old water line is where the old boiler kept the water line. And off to the right, in part of the picture you don't see, there were some returns that were tied in which were below the water level. But now that this new boiler is going in with a new water line, some of those returns, or maybe more returns, might be exposed to become dry. So the steam's going to go through the system, go up those returns, and stop the heating in those other loops. Again, when you have the same pressure on both sides, supply and return pipes, nothing heats. We need that difference in pressure. By going to this new boiler, we have this low water line that's a lot lower. And so we have to say, well, let's keep the old water line where it was, and this problem would not exist. So we build that old water line where it was. We build the new water line where the boiler is with our new Hartford loop. Everything works fine. Had a job one time that the call came in, and half the building wasn't heating. It was actually a commercial application, but half the building wasn't heating. And that's exactly what they did. The old boiler was a very tall boiler, and it was in a manufacturing plant. So when they got the new boiler, the water level was, probably 35, 40 inches off the floor. But the old water level was about 8 feet off the floor. So they had to build this false water line, and they made the system water line way up where it used to be, and a new boiler down where the new boiler is. And system worked fine. So they went from not heating half the structure to heating everything fine by adding this idea, this false water level. Not nothing new, but it's been used many times through the years. So try and get the boiler up on block residentially. Try and get the boiler up on a block or two to where your water level is fairly close to where it was, and you'll have less problems. So this brings us to the end of this primer for near boiler piping. You can see on this slide other seminars that we do that will be coming. I am retired, so I kind of take my time at it. I don't rush into it. And we have plenty of things coming out in 2024. Just bear with us on when. you want to see one of those other seminars, you can shoot me an email, and that would be the next one I could work on, whichever one's the most popular that wants to be seen. And you can scan the QR code again to go to our website, get the seminar information as it becomes available under the seminar tab. You could call us or drop us an email if you want. But that brings us to the end of Near Border Piping Primer.